Great.
Boom.
Yeah.
Awesome.
Thank you.
Okay.
Now we got to figure out where it goes.
Into some.
Okay, so I work for Foundation of Success. We've been around about 25 years. Our mission, we're not for profit. Our mission is to amplify the collective impact of the global conservation community. We have a branch here in North America, also affiliates in Latin America, Europe, and Southern Africa. We provide training and coaching, develop frameworks and tools, facilitate collaborative learning, and build capacity to the future. But the short tagline to think about what we do is we don't actually implement conservation work. We try to make other people's work better. And so this presentation has two parts: the conservation standards and Marathi software, and then there's a bonus presentation on taking your work to scale. Let's start with this first part. So as you all know, conservation takes place in really complicated systems. And what we've learned from that is if we have two identical pieces of forest somewhere, one has a community that lives in one corner of it and they hunt throughout it, and the other, no human being has ever set foot in it, completely pristine. So the question is, which is more effective, which is more effectively conserved? The pristine one or the one with the humans in it? Anyone want to guess? You know, it's a trick question. All right, here's the trick, right? So if I give you additional piece of information, in 6 months, a large logging company is going to come and clear cut that forest. Okay. So clearly in that case, we would say this one is better conserved. But if we're relying on purely biological metrics of outcomes, how is the forest condition? How are the critters doing? We don't know anything about what's actually going to happen to that forest, because that forest takes place in a complex system, and we have to understand the biodiversity we care about and the benefits it provides. But we also have to understand human direct threat behaviors, and we have to understand the actions that we can take to change that stuff. So effectiveness requires understanding both outcomes, but also practices along our theory of change pathway in that complicated system. So back in 2002, a bunch of groups that you see here, we're all interested in trying to make our projects and programs better. And we all got together for a half-day meeting, had so much to talk about, we turned it into a regular thing. And we discovered we were all doing similar things, but we confused the heck out of each other with words. So how many of you have ever been in a debate? What's bigger, an objective, a goal, an outcome, an output, all those different terms that people throw out there, right? It's all word salad. We also went and looked at what the rest of the world was doing. Lots of other smart people in lots of other fields have been thinking about this stuff. So each number represents a different system for doing performance measures or learning that we studied. And we boiled it all together to create the open standards, which came out in 2004, version 1. We learned a lot more. We created version 2, version 3, version 4 in 2020, and now we're working on version 5. The standards are a set of practices for doing conservation work: assess, plan, implement, analyze, adapt, and share. You might be saying, I've seen that before. Yeah, you have. If you think about Deming or any kind of project planning, it's the same basic principles. It goes back to the scientific method back to 2,000 years ago. But there's a set of tools and techniques for doing conservation that are a little unique to what goes on here. So today, the Conservation Measures Partnership includes all these different organizations, funders, implementers, and governments. And we have a new member as well, which is you all. Woo! For us, projects are the basic unit of conservation. So you can think about a project being out there in space, maybe some people doing some work on the ground somewhere. They're going to have a project team that's implementing it, and they're going to take one or more of these theories of change to work on and change and achieve certain goals, both for human well-being and for conservation purposes. Projects are also organized in something bigger called a program, which is usually an administrative or funding unit, but can also be a bigger thing in its own trying to accomplish certain things. So think about across all your work. I know your place-based work, but even many of the other work you do, you can kind of start to chunk it up into projects and programs. So the very simple version of the standards, and this is a very basic example, is say we're working with this community out in the Pacific somewhere. We're trying to help them manage marine resources. The standards first say, what is your scope? Are you trying to manage one bay or an entire ocean? Both are acceptable, but it matters what your scope of your work is. Who's on your team? So who's involved in this work? And a core tenet of the adaptive management work that we do is that it can't be an outside consultant designing it. The project team members have to be involved. People implementing it have to be involved in that work. We then ask people to come up with a model of the system. Conceptual model system sounds scary, but it's basically, if you go back to Peter Senge, every one of us has a different interpretation, a mental model of what's going on in the world. We need to harmonize those. So we need a way to talk about, well, what do you care about? Well, we care about turtles. What's a threat? Well, maybe they're being harvested for someone's dinner. We care about fish. Well, they're being commercially harvested, but they're a protein source for the village. Let's come up with that common picture of what's going on in the system. And then we're going to figure out how we're going to change the system. We're going to plan our actions and monitoring. Years ago, I used to work at MacArthur Foundation. My boss, Dan Martin, he was in the military. He says a strategic plan is not a 200-page document that says strategic plan. It's when you can tell me, what are you going to do, but also what are you not going to do with your scarce time and treasure? And so the standards give us a bunch of tools to prioritize threats, to see which targets need most attention, and what can we do to change the situation. The crux of it is we then plan how we're going to change the world. So in this case, this community said, 2 generations ago, we had a really cool indigenous no-take area where we do these seasonal closures, and that would lead to better management. We lost that when the fishing got commercialized. Let's try as an intervention to bring that back. Let's bring back that traditional harvest taboo. So that's an action you could take. In this case, that action has an assumption that if we do that, clams will reproduce in the no-take areas. If we do that, we'll have a healthy clam population. If we do that, we'll have spillover effect. If we do that, we'll have more clams with community harvest. For those of you who are sciencey, that's a hypothesis. That's we call it assumption to be a little friendlier, but it's a hypothesis or an assumption. And on this theory of change, we can then put our goals and our objectives, which would be SMART, specific, measurable, all those different things, which will help us chart our progress. We can come up with indicators to track our success. And most critically, we can also put evidence in the assumptions that we're making there so that we can think about uncertainties and where evidence fits. So for us, these theories of change are incredibly important to lay out the logic of what you're trying to accomplish. Okay. Then you actually implement the actions in monitoring. So here we're going to set up the no-take zones. We're going to count clams inside and out. In this case, we're going to take the data and we're going to analyze it from those indicators. And the blue are the numbers and sizes of the clams we had to start. The orange is after the intervention. Woohoo, it worked. In this case, we actually got more clams and bigger ones. But often you find it doesn't work. Well, that's okay. Real failure is trying the same thing over and over again and not learning from it. So what we want to do is learn from what didn't work and then use it to iteratively, adaptively manage the system. For those of you who come from the computer world, this is agile. This is the equivalent of agile as opposed to waterfall work in terms of the computer world. But we want to learn and get smarter. And then we want to share our lessons with our team, but also with the rest of the world. So effective conservation practice for us is going through these standards. Although if you're a large agency like the Fish and Wildlife Service, you might have your own version. USAID had its own version that they work on. We've actually spent 15 years working closely with the USAID to take a lot of this stuff and stick it in here and build it into what USAID does across all its programming. Or there's a version of this that was developed in Australia for work with Aboriginal groups. They didn't like all this sciencey jargon, so they came up with their own terms for going through the cycle. So there's lots of ways to do this work, but the key thing is to be going through this kind of iterative agile process. We apply a lot of things that might be relevant to some of the work that Daphne shared with me. So you guys are about to launch your fire stuff. I've just spent the last 6 months developing theories of change with Resource Legacy Fund in California for all their wildfire strategy work. So I know a lot about the fire stuff in the West right now. I'm part of a thing called the IUCN World Commission on Protected Areas. They have an effectiveness task force. My colleague Paul and I are the co-chairs. We're charged with helping under the context of 30 by 30, helping the world's protected areas do better effectiveness measures, drawing on these principles that might apply to your Sentinel work, to your Central Asia work. There's lots of things and ways in which I think this might apply to the work you're doing. That example I showed you was a very place-based kind of specific example for teaching purposes, but a lot of the biggest value is these more conceptual, theoretical, or thematic projects that people might be working on. All right, that's the conservation standards in a hurry. How am I doing? Okay. You guys with me?
Very fast. You could slow down a little bit, but you're doing fantastic.
Okay, I'll slow down a little bit. Second part this is about Marathi. So you guys are a tech shop. So as you probably know, tech is really important to this whole world. So if you think about a typical organizational IT ecosystem where you assess, plan, implement, analyze, adapt, and share, you flatten that out into a business process. Organizations like yours, like others, go through a whole bunch of different business processes to support their work. Right? And to do their fundraising or their financial management, if I was on your board and I asked you, how do you do your financial management? I'm pretty sure you have a software system that does that in some way, that supports that work. Same for fundraising, same for people management. And if you didn't, I would be a pretty grumpy board member. Okay? But then you ask people, well, what business systems do you use to support your conservation plan? And you get email, MS Office, a lot of PowerPoints, a lot of different things. Okay, that's not really acceptable. So we developed Marathi as a software system to actually support this process that people go through. So Marathi is a software system custom designed to take people through these conservation standards. It's a bunch of tools that helps you lay out the scope of your project. You have a homepage on the web for your project. You talk about your vision, who's on your team, You can control who sees the information. You can then come up with a situation diagram. So remember the pictures I showed you, we tend to do it with these box and arrow diagrams, but a picture of the system going on, and it supports that work, and that can be updated and adapted over time. Threat ratings to do prioritizations, which threats are most important. Another kind of diagram, these are those theories of change. So we provide tools to support those theories of change. Set up SMART goals, objectives, and indicators. We can actually coach people through that process of coming up with good SMART goals and objectives to come with the outcomes. Work planning, so you can track who has to do the tasks and work and do stuff, track your progress over time. Analyze and adapt, so you can kind of see how you're doing vis-a-vis your goals or objectives or what you need to change. Lots of classifications, which I'll come to in just a second. And then you can share your projects, or there are libraries of information. So Barati is just a tool to help people go through this conservation standards. You have the postcard, free trial, you're welcome to try it out. The part that I think is most relevant to this group is what we've really created through Barati is a standard way, a semantic understanding of conservation work and a way of thinking about conservation. And so we are actually putting together a one of these Bezos Earth Challenge Prize funds, which you all are partners on, and it's trying to get at this issue of what I'm about to share with you here. If you take that as being a typical conservation work, and that's your problem, if one group calls it cows, the next cattle, the next livestock, the next grazing, the next ranching, you don't realize you're all dealing with the same problem. So especially for the diseases, threat reduction results, and also for actions, we said that in 2007, we need to come up with a standard way of talking about those things. So the Conservation Measures Partnership started developing a classification, as did the IUCN Red List folks. We found there was so much overlap that we joined forces and created a set of unified global classifications. So what we now has a standard lexicon for how to talk about threats and actions, and so and how to do this in a semantically common way. We're just about to update the version 4 of this, so we're working on updates to these classifications through the Conservation Measures Partnership. More interestingly, this is where the learning comes in. Let's take one specific example. Let's say we're working with a community in the Bahamas somewhere, and we care about turtle eggs being poached on the beach. So we have this brilliant idea that we're going to set up community guards as an action to change this. And our theory of change says if we do that, the guards are deployed, they'll catch the egg collectors. More importantly, their presence will deter other egg collectors from coming on the beach. Egg collecting will be reduced, we'll have better sea turtle nesting success. Let's go to another part of the world, another specific project in Africa that cares about pangolin poaching. So in this case, pangolins are being poached. We're going to set up something we're going to call community ranger patrols. And here, effective patrols are deployed. They apprehend the poachers. Their presence deters the poachers. But in this case, we learned something, which is if the poachers are the people's neighbors, the community rangers can stop them. But if the poachers are drug gangs with AK-47s, they just literally get blown out, and it's not going to work. So the answer is never does a conservation strategy work. It's always under what conditions it works. And if you notice, these are two totally different parts of the world, different biomes, different species, different cultures, different everything. And yet the underlying logic of what they're trying to do is very similar. So we can take 10 examples in different parts of the world that are all trying the same strategy, more or less, come up with a common name for that strategy, and create a generic theory of change that encapsulates what the world knows about that problem. Okay. So what we're doing is, if you're the traditional data and information knowledge wisdom pyramid, we're taking data about individual actions that people have taken, we're synthesizing them into knowledge, and then that knowledge can come back and be used by informed practice and the rest of us. And what we've tried to do is create this CAMEL database, which is online, which has these generic theories of change. The problem that we've run into is that most conservation information is not shared. It's not online, it's not electronic. There are 5,000 projects or 10,000 projects in Barati, which is one start of that electronic format, but a lot of it isn't. So what we're proposing to the Bezos folks is to actually create a vacuum cleaner that would take all the different information that's out there that organizations could use. But it's not just text-based analysis, it's using the semantic understanding of the conservation standards to take all that information and turn it into records of conservation action that can then be mined and put to this whole thing. So that's a whole set of action that we want to work on. That is a ton about the conservation standards in Barati in a very short time. Let me pause there, but Daphne wants me to focus on scaling, so I'll go there next. But let me pause and see if there's any questions or thoughts.
a question, but I'm gonna wait until the end. I don't know if you guys want to jump in, if you have it, want it.
I'd love to talk to you about the fire strategic planning with RLF later on, but we can do that after the meeting. But what would the database look like with the basis or the fund? Would that be accessible to all conservation practitioners or?
So there's an issue of data ownership and security, of course. You might have heard of it. And when we started Marathi, part of our idea of Marathi is that most people would be willing. So Marathi gives you different permission levels. You can have your information totally public, or you can keep it to members of your organization, or you can only keep it to members of your program or project team. So you have that kind of security. And my hope had been that people would make their stuff public, and they haven't. I mean, people are reluctant to share failures. There's a long history. We'll get a long discussion about the behavior incentives here and how all that functions, right? So we're thinking that when we do this Bezos machine to sort of vacuum up all the data, and there's also a question of, is it trusted data? Is it junk that's being fed in there? So we thought we would train it and start within organizations, where organizations could, like Bush Heritage is in Australia, wants to look at their records for the last 30 years. Everything's in Marathi, so they're pretty easy. I'm working with the Summit Foundation. They want to review their Mesoamerican reef work over the last 30 years. So at least they could start with the training the machine and keep the data internally. But I'd love to figure out the incentives, and this is where the scaling stuff comes in, the behavior change to make it people willing to at least anonymously or share or be more wide. So we're cognizant of the barriers, but we would like to overcome them. Is that fair?
Definitely.
Question actually along those lines, because I guess in the econ world, with that whole reproducibility crisis, econ sociology, one way they address that is by requiring people to pre-register their hypotheses. And so then when you pre-register, then if you find that your hypothesis is invalid, then that ends up having to be, there's a mechanism to make that public. You all seem to be in a really good position to try and start establishing such norms. Have you all thought about it?
We have, but we haven't succeeded. I mean, this has been a big, I think, challenge facing the Conservation Measures Partnership. And now that you all are part of it, it'd be great to see if we could sort of crack this nut, especially, whether or not we get the Bezos funds. I mean, this is something we're going to do anyway. So how we work towards this. And to me, it's as much as, a social problem as a technical problem. And in fact, it's more of a social problem than a technical problem. So that might be a really interesting way to think about that. I think one way we tried years was to get the funders on board and say, if, like, my wife works for the Human Genome Project, and in the genome world, if you want to publish, you have to deposit your sequences in one of 3 databases around the world. Or if you want to get government funding, you have to deposit. So could the funders mandate some kind of transparency where if you take our funding, you have to publish your results? I don't think that would be a huge stretch. It's been hard to get the donors to do that. So
I'm gonna ask one question, which is along that. To what extent have you seen, just thinking about science for reproducibility, a bit of a reproducibility crisis right now, right? But reproducibility is one of the foundations of science. To what extent have you seen reproducibility in the conservation world, particularly as you've worked towards standardization?
So, I mean, and this is, like I said, my wife is a genome scientist, so I get to compare my work a lot to hers. One thing is that the order of funding they have is about 5 more zeros or 6 more zeros than what we have. And strangely enough, the level of complexity that we're dealing with has probably 3 orders or 4 orders of magnitude more complex than even the stuff that they're doing. Because if you take a coral reef that is being bomb fished by people driven by a human socioeconomic system, I guarantee you it's pretty close to the most complicated system in the universe. I mean, if you throw in the biodiversity confusion with the human socioeconomic, it's got to be up there in both the detail and dynamic complexity. So the replicability problem, it works pretty well. If you look at what Bill Sutherland or conservation evidence folks do, they're able to kind of apply more evidence-based medicine principles for what I call the gardening strategies. Like, if you spray herbicide on this plant, does the plant die? Okay, there you can control enough of the variables that you get standardization. But when you get to the levels of these kind of more socioeconomic interventions, I don't think we don't have the ends yet, but things rhyme. And that's where I think having these underlying theories of change, you may not find complete concordance across the entire theory of change, but you might find it across key assumptions. Does going after a community allow people to get a psychosocial state where they're then willing to sort of entertain a behavior change? that's the level where I think we can
Yeah.
start to think about replicability.
I'm just wondering if there are certain things, like certain theories of change or certain pieces that, you know, are more supported.
Oh, yeah.
Right? Over
Oh,
time and time again,
absolutely.
we know
Absolutely.
if we do this, this is the effectiveness of that.
Well, let me slightly add a wrinkle. Over time, we know we do this in these conditions will lead to that. And then it's the conditions, it's that conditionality that becomes so critical to this whole discussion.
Do we know what happens in when those conditions are not true? Like how often that works or how much?
Yeah.
I mean, it seems like statistics, there's plenty of statistics that could get principal components analysis, other things like that you could apply to this problem that are used in fields of ecology, right? The N evolution that we've looked at, it seems like, you know, we're stuck on randomized controlled trials, which is great, but it's simplistic in terms of like our thinking.
I think there's a place for RCTs. But one of my taglines that relate is that we get a lot of, so in the conservation standards world, I would be a little whiny, I don't know, whingy here for a second. We get a lot of grief. We get a lot of shit from the academics who say, okay, your models aren't gold standard. You're not doing the double-blind controlled studies. You're not doing the systematic reviews. You're not doing all these things that to publish in Science or Nature you need to be able to do, right? And on the other hand, we get a ton of grief from practitioners who say, you want me to take half a day to sit out there and lay out my theory of change? I don't have time for that. I don't have the ability to even do the basics. And so what I've become a huge fan of is there's a time and place for the gold standard, but I'm a fan of the aluminum standard. Cheap, recyclable, lightweight, and that can be done fast. And I think we're walking this kind of edge of using science in a really interesting way, but not necessarily the gold standard. It's not that I'm against the gold standard. There are places where you need it, but in the vast majority of things, I'd settle for aluminum.
Let's keep,
Yeah, keep
this
going.
is fantastic. I am worried that we're gonna run out of time though.
Okay, scaling.
Yes.
All right, she asked for it. You can blame her. It's all her fault.
I think the scaling work will really resonate, so I want to make sure we get to it.
Okay. And again, I'm happy to share all the stuff we can get, and I'm happy to go into a much more detailed conversation about this.
We appreciate your traffic cop.
I have to show you one last slide. So the one thing back here I was going to show you is that there's a whole bunch of, what I showed you is the Conservation Standards 101. There's all these 201 sort of higher level topics we get into. We're doing the scaling one, but we also could talk about evidence. We could talk about all these other fun things as well. All right. All right, so you know who we are. I skipped that. Okay, so this work is based on the conservation standards, but a whole lot of work we did with the GEF on kind of nature-based scaling. And then I actually worked on a book that kind of thought about this stuff as well. So there's a lot of interest in going to scale. We go meet with a large conservation group and they say, we're going to scale up restoration natural ecosystems, sequester a gigaton of CO2 in the next decade. Okay. Or 30 by 30, we're going to protect 30% of the world's planet by 2030. Okay. And then you ask people, well, how are you going to get there? Well, we're going to do some pilot projects. And we got this lofty ambition, and some magic's going to happen, and people are going to pick up those pilots, and we're going to get there. That wasn't acceptable. So we wanted to see if we could actually take conservation work to scale and develop guidance to help teams. So we did some work, and this is work that was funded by the Moore Foundation and also somebody at Walton Family Foundation. Anyway, there are 3 streams of practice that came together here. One is taking actions to scale. There's a whole literature about that. Promoting behavior change and harnessing networks. So real briefly, if you look at scaling, you go through the business literature or the systems thinking literature, there are dozens of frameworks that look like this, maybe even hundreds. And they're all different flavors of how you sort of take a pilot and move it up, and different kind of things like this, and jumping up and all these kinds of different things. So we kind of studied all those. The one we really liked was Moore, which I'll come back to in a little bit. We also thought this was a huge behavior change component of this. So our friends at Rare have this really interesting way of thinking about behavior change and different levers that you can do to change behavior. There's a lot of other frameworks like that as well that are out there that cover different things. We boiled it down into we're really fans of like harvesting what everybody else has done and then trying to figure out how to name it. But sway me, norm me, nudge me, make me, tempt me. It's a whole bunch of levers that you can use to change people's behavior over time, get undesired behaviors reduced or desired behaviors increased within the system. And then the last is networks. We ran into this guy, David Santola, he's a professor at University of Penn. He's been studying networks. And what he's found is that if you want to do traditional ice bucket challenge, kind of easy change, yeah, you can go to the influencer in the center. But if you want to go to difficult change, it does not happen at the center. It actually happens on the periphery and spreads from there for a number of technical reasons. So we kind of worked with him as well in his theory. We're a big fan of learning by doing. So with the funding support, we actually funded 6 real-world projects or programs that were all trying to scale an idea. And then we spent 2 years working with them and studying them and trying to build up our framework. The idea is that we can learn with those programs, we can learn across the network. And then what I'm doing here is sharing that information with the rest of the world so people could benefit from what we did. So as examples of the programs, the Nature Conservancy was trying to scale sustainable farming practices across farmers, but mainstream farmers across the Midwest. BirdLife was trying to stop the illegal killing of birds in the Mediterranean from a number of different sources. They were trying to do indigenous-led conservation coming out of Australia and trying to spread that around the world, spreading adaptive management of protected area systems from Latin America to the rest of the world. Working on CI has this really cool idea of if you want to do intensification of shrimp farms, instead of doing it with gray cement and lots of medicine, lots of drugs, you can actually bring in mangroves and do a restoration with it and then try to spread that around the world, this idea of climate smart shrimp. And then RARE has been working on scaling coastal management of fisheries and kind of bring them in interesting ways. So these are all sort of 6 core concepts that people had. They've done some pilots, but they wanted to sort of come up with a plan for moving that to wider scales. So here's our framework in a hurry. There are 5 approaches for taking a pilot concept to scale. We need to bring in behavior change and networking theory, systems thinking, and then we'll talk about how we actually do it. So the 5 approaches, and this came from building on that one reference I talked about in the scaling world, is that one way to think about scaling is you have 2 initial pilots, your initial core concept. One way to scale is just to make them bigger. You just expand the size of the work you're doing, the footprint of them, build out your project team. And there's a whole bunch of assumptions behind this, a theory of change that we developed, and I'm not going to go into today, but we developed the whole theory of change of what this involves, what the assumptions are, what can go right, and then test it across our different things. When did this work? When did it not work? The second is you replicate in programs. So instead of trying to expand your footprint, you try to replicate your footprint, but you're still managing it. You're still doing it. You're still hiring the teams and kind of doing all that work. People think there's a lot of efficiencies there. They're not. And there's lots of interesting things that emerge from that.
Wait, so sorry, what's the difference between expanding, if you're running it either way, what's the difference between expanding and replicating?
So in this model, it's the same team, it's the same project team. Where here you're actually trying to clone a whole bunch of project teams across the landscape. And it can either be where you directly manage it, or you can also franchise it. You can do it more in a business franchise model.
But in either case, you're gonna have to hire more people.
You have to hire a lot more people, and you have to manage people, and you start with the high hanging fruit, and you end up with the So there's different. They're sort of similar, and that's actually why all 3 of these are actually in what's called scaling out here. The third is diffuse the concept. This is what most people think about when they think about scaling, which is you come up with your idea and you publish it, and then other people pick it up and implement it for you. But all of these are scaling out in the sense that they still require doers. They require people doing the work, hiring teams, kind of doing the work. It just depends how much you control it and how much you manage it. As you'll see, the fourth, and this is where it starts to get interesting, is rather than scaling out, you change the system conditions. So you don't worry about working at the individual project level, but you actually try to change the system. You change policies, or you change market forces, or you use market forces, or you use different things to sort of change how the world happens. And then the fifth, and this is what the scaling people called scaling deep, and we were really confused with this. We didn't actually know what the hell they meant by it. Over time, it's becoming a little clearer. It comes back to Damon stuff and networking. It's about creating norms, maybe on the periphery, and then creating this network where it becomes the norm of what you do, and things spread through the network and get picked up. So what we learned is that effective scaling requires using the right mix of these approaches. There's no one magic answer. You have to kind of mix and match these things together. And so how do you pick which approach? And so here was our big aha. If we start with this idea of projects or programs, which is what we tend to do because we're in the NGO sector, and so what we do is we do projects and programs. This is our business. It imposes a fundamental bias of you're setting up these projects and programs. And so we said, let's erase that. And let's actually start with the system. Let's think about what the outcome is that we want to achieve in the system. And let's think about the behaviors involved in that outcome. Because almost everything in conservation involves somebody either doing more of what you want them to do or less of what you don't want them to. So it's a behavioral problem. And so if we can think about those actors and what behavior we want them to do, and then we can think about the leverage points in the system. So Dana Meadows, who's a big systems thinker, had all these ideas of leverage points and where the higher leverage points are. But that if you can change intent and design, you can actually move the system a lot faster. I'm trying to get all of it. So what it ends up looking like is you might think about your primary actors and your ultimate outcome. What are the barriers to them adopting the behavior you want? What are the enablers that get them to adopt the behavior you want? And what can you use these behavior change levers to change them? Or often what you find, it's not them, but there's some secondary actor or even a tertiary actor in the system that you have to change in order to ripple through the whole thing. So this involves mapping this out and understanding that. So in the shrimp case, they started off by saying, we want these shrimp farmers to adopt this climate smart shrimp. Well, they need some money to get this done. In fact, it costs, if they do extensive farming business as usual, they make about net present value about $500,000. They don't have to invest anything. If they intensify with concrete, they make 4 million, 5 million, but they have to invest 4 million. Climate smart shrimp, they make money, they make 2 million, but they need 2 million of intervention. And then the restoration, we have to pay all that up front, it'd be hugely expensive. So in this sense, they're willing to adopt climate smart shrimp, but there's this huge barrier that they don't have the cash necessary needed to do it. But that's also an opportunity. So I'm going to take you back to high school physics. Remember when the ball was on the hill and the ball wants to roll down to the bottom of the hill? We've come to this metaphor that if we want to think about scaling, we have to understand, is the system primed to roll down the hill, or is the system primed to work against us? So you have a downward system tilt, where here we just get over that barrier. So in the shrimp case, the farmers are going to make money. So they'll want to adopt this, but they got this hump of needing that initial upfront money they need to start this thing. You might have a flat system where the ball is kind of has to be pushed along over a series of humps. Or you might have an uphill system where you push and then you stop pushing, the ball comes back and smushes you. So if you understand, I'll skip over this, how we define tilt. It led us to a decision tree path across those different scaling options. So if you start with a core concept, your scaling team, your ambition, your actors and behaviors, which is no little thing, actually it takes a while to get here. We ask, what is the overall system tilt? And if the tilt is downhill, if it's working in your favor overall, then you ask, can I remove those barriers of a system? And if I can, I'm going to use approach 4 and then get enough people adopting it so that approach 5 takes over. So I'm going to dispense with projects and programs. I'm just going to work at that system level and get this thing done. Does that make sense? Okay. If it's downhill, but the barriers can't be removed systematically, then I'm going to have to bring in approaches 1 through 3. I'm going to still have to set up projects and programs to push to get those barriers out of the way, because I can't work system level. And then hopefully this comes in. If the system tilt is flat-ish, then I ask, can the barriers be removed at the system level? If yes, I can change the system conditions to remove the barriers, but I still have to do projects and programs because it's flat. I got to push the ball along. It's not just going to roll. And then we get to the norms. Here, you're in this case, that's the same case, basically, where you have to push it along. And if the answer is uphill, and you got to get good at spotting these uphill ones, right? You spot these uphill ones. If the answer, then you say, "What? You're right. You're right. Can you change the system tilt? If you can, then you may change some policies or do some work to get the system tilt, and then you start over." Our team really didn't want to give up, so before they went to where you went, they said, "Well, can you expand your coalition to change the tilt?" They really felt important to not give up or try. But if you can't, then you triage. Then you find another system working. And we have to get smarter about finding, because we are spending way too much time in conservation pushing balls up hills that are never going to work. And we got to get smarter about that. Okay, so that's the overall decision tree.
How do you measure the system tilt? Is that like a vibe, or is that like, we know that?
Can I finish the presentation? Then I promise I'll come back to it.
Yeah.
I will answer that question. I'm not trying to dodge it. I will come back to it. I just want to show you a couple more things, and I'll come right back to that. What it led us to here is that you have the primary actors adopting desired behavior. Then maybe the secondary, they're your initial scaling target actors, but you may find you have to work here or even here. And so in a country where policy change is needed to implement, say, like what Rare is doing with the coastal areas, you need to have local people have the right to be able to manage their areas. And so maybe you start with the policy people and work through here, and then you worry about that, and then you get, but if the policy is already in place, then that tilt is more downhill, then you can work directly with the actors there. So it's somewhat conditional. It goes back to, it depends where you're working and what the system conditions are, understanding that. In this climate smart shrimp case, here what was so interesting, they thought they were in the business of helping demo shrimp farmers to adopt this production. Once they did this analysis, they get, oh, we are never, because if you look at the amount of money to get over that tilt, I think if they did the back of the envelope calculations just in Indonesia, it was going to cost $20 billion. They don't have $20 billion as an NGO to do this work. But what they found is that if they can think about local financial institutions, there are a lot of ag and development banks in the world that invest in farmers and do this kind of stuff. And what they found is if they could focus on these guys and they could set up a fund that demonstrates that you can make money pushing climate smart shrimp, then you can actually get these people on board. So they got out of the shrimp farm pilot business and they went into the shrimp fund business, which required them hiring a bunch of bankers and fund people, not ag extension agents and things like that. So they totally retooled. And there they discovered the tilt was more flat. Because they're not going to make huge amounts of money compared to other things, but they could make some money and they could kind of push this thing along. So now they're in kind of more of the diffusion of the concept idea and kind of looking at things. So now their scaling theory of change looks like we spend $1 million doing business case, making the business case with pilot grants in Ecuador and Indonesia. And that's grant funds. We get some impact funds to get $100 million in place to do the first or one or two of these investment funds. We showed that they work over 2 to 3 years. If we do that, then financial institutions decide to invest in climate smart shrimp at scale, and we can influence the $34 billion shrimp sector. There is 20 billion in this sector. You just have to tap it. You have to be smart about how you get there. But I hope you see that rather than kind of this vague, some magic happens, what we're trying to come up with is a very deliberate scaling pattern. It still may not work. I mean, it's conservation, it's hard. But at least you have and then you can go back into the typical conservation standard stuff, plan, adapt, kind of figure out, take your metrics and sort of figure out what's working over time. So that's a ton in a hurry. What we've created is the FOS Scaling Challenge, which is a framework to take your own program to scale. And basically in 6 hours, we ask you to take an idea and go through these 6 steps. Actually, we're about to release version 2.0, which only has 5 steps, but describe the core concept and units, just depict your actors, your scaling ambition, your tilt, your scaling approaches, and then do the math. And then you make a go, no-go decision, depending on what your tilt is, and then you develop a full scaling strategy. And so we've been applying this with a whole bunch of different groups to sort of think about their scaling stuff. If that would be of interest, I'd be happy to try it out with 1 or 2 or 3 of your projects. It works really nicely in a workshop setting to think about scaling. So that's a ton in a hurry. Let me answer that question unless there's other more burning questions. I do want to come back to the question that was asked.
Take that one and I'll follow up with one other, and then that's probably our endpoint.
Okay, so you asked, how do we measure tilt? So
We're hearing a little background noise. If Grace, you could just mute.
So I showed you those tilt graphs, and they're sort of a metaphor. I mean, they're a metaphor for how to think about the system tilt. But what we've actually been working on is how to make them actually more measurable and metric. So the one question is that an uphill tilted system? Or is that just a barrier in a much bigger downhill tilted system? So part of this depends on your perspective and how zoomed in or zoomed out you are of the system and where things are. In some ways, we kind of think that tilt is the sum of all the different barriers and enablers that are out there. And so we have some tools that help people catalog and then rank and weight these different barriers and enablers that are out there to that behavior. But it's also appearing that some of these are more showstoppery than others, and so that we might want to think about them. And since you guys are geeks, I'm going to totally geek out for 1 second because you asked. And so part of what we've been actually thinking about is if you could actually, rather than just treat this as a metaphor, but actually make it something measurable. And we're still struggling with this, isn't perfect. But if you think about this as the percent of actors adopting the desired behavior, and this is in a downhill tilted thing, as you get more actors adopting, it becomes easier and easier to spread and reach your scaling ambition. But there may be these barriers here that keep you from getting here. If you believe this, so is it a metaphor? We actually use to measure system tilt. If you believe this, then you can do some calculus. You can actually look at the total effort you need to move all those actors as the effort underneath that curve. And so you could measure system tilt as y0 minus yf, depending on what you choose to put into those axes. And so we're actually sort of playing around with, but then the question is one of these a killer? It kind of breaks down a little bit. So this is something that we would love to find people who are inclined to think about these things to help us think about. How was that for a geeky answer?
I love it. I love it. Lindsay, did you get your answer?
Yeah.
You know, I was just looking at a note here, right? The example you gave, right, where on the mangroves, we're $20 billion, this is an uphill tilt, right? And so we reset system norms or we give up, right, as our two alternatives. And I forgot the middle box that means don't give up before you give up, right?
Coalition building.
Coalition building, which is interesting, right? It's a different, it's interesting to think about the coalition building. My bet, and this is hand wavy, is that most of environmental problems are actually that case. That most of the examples where it's a downhill slope is very few and far in between, and we already have them, or we've changed them because of policy, national parks in the United States. You know, we've gotten rid of subsidies, which I think is like a huge driver. But most of these other examples are these systems that are, you know, uphill slope or very, you know, very difficult to solve. And it makes me think that the solution set, and this comes to a second question I'm going to ask you, lies outside of conservation for almost everything we are doing. If we look at the big problems we have, the solutions have very little to do with conservation. And so like the last 50 years, we really haven't been able to do it. And we have a project called, it's a drawdown for extinction, where we try to focus on these solutions. But one of my big worries is that we use things like IPBES and others, where the solutions are all based largely in traditional conservation activities. And what we need is to take your lexicon and be able to expand it to other solutions that are alternative proteins is one that we're working on that might be way outside the field. But I was wondering, you know, first, is there a way to expand that set of lexicons to kind of non-traditional solutions, and how would we go about contributing to it? The definitions paper, I think you had shown us in 2008 in conservation biology. And then, you know, what is your sense of like how many of these things are actually uphill tilts?
So it's a big question, and I have 1 minute to answer it, but I will do my best. I mean, to your broader point, that's why I started with this. Remember this quiz I showed you? Conservation has very little to do with this. So I completely agree with you. Conservation is all here. This is where conservation action and effectiveness takes place. Very little to do with this, but it has to link through. You still have to understand the linkages through to where it goes and what it does. So it's much more a social problem than it is a biological. Full stop. I do agree with you that there's not a lot of downhill tilted things in the world, or that they tend to take place in first world problem places where there's not resource pressures. And a lot of what we're learning is that what drives the tilt is not just, well, let me say the other thing. So, but I do think what we're finding as we apply these is that from a Pareto optimal or societal optimal point of view, these things can be downhill. Like if you do protection and production together, you are going to have over the long term better social returns, better economic returns than if you just strip mine the coral reefs or the forest or whatever it is. So long term, from a way zoomed out point of view, it can be somewhat downhill, but the barrier, which is effectively uphill in the short term, is the vested interests and the powerful people who are making money over the short term. So it matters who's making the money and the individuals, and sort of understanding those barriers from that point of view. So I do think it's hugely uphill, but I'm actually strangely optimistic. I do think that long-term it can be downhill. We gotta get over those humps. And so I think a lot of the actions and the tools, and I can show you the actions classification at some point, are about, the more interesting ones are not the gardening ones. How do I spray a herbicide? It's how do I change the behaviors of policymakers to get them to crack down on the elites so that then people benefit.
Awesome. Thank you very much.
Thank you so much, Nick. I'm already getting messages in chat saying, can I get the slides? I want to think about tilts. So this is a start of, I think, a longer conversation. And thank you so much for helping us zoom out as well. It's been very helpful.
Encourage you to take the scaling challenge, either on your own or we can go do it with you all.
Thank you so much.